Hi guys. So today we're going to go over geometry. It does involve a lot of vocabulary, but these um, terms are really important to know before we move on to more difficult things in math, whether it be area and perimeter, or different aspects of figures like finding side lengths. So let's start with what geometry is. So geometry is the measuring of shapes. Okay, that could be the side lengths, that could be the amount of space in between. Then we have terms that have to do with points and lines. So we've gone over these before, but let's start with point. So a point is simply a dot, like on a map, it might show you where a city is inside a state. So it might point out like Jacksonville in Florida would be a point on a map. Then you have a line segment. This is a line that has two endpoints. So you have the line in the middle, and there's a definitive start and end to that line segment. We have regular lines. Now, a regular line has no endpoints, so it continues on forever in both directions, which is why it has an arrow on both sides. And then there's a ray, which is a line that has one endpoint, so like a stopping point, and then an arrow on the other side. So only one side of this line goes on forever in just one direction. So it looks like this. Next, we're going to talk about an angle. So an angle is formed when you have two rays that share a common endpoint. So if you look at the image there, you see that you have two rays. They share that same little dot, the endpoint there, and it shows the angle in green that it forms. And the vertex is the common endpoint where the rays of an angle meet. Okay, so it's not that little green part inside like in the previous picture. It's actually the point where those two rays meet. So it's like the corner there, the point. When you have intersecting lines, okay, think of like an intersection in the road. There are lines that cross each other or go through each other. Intersecting lines look something like this, or they could be more spread apart. And then you have perpendicular lines. Now, perpendicular lines are intersecting lines. They do cross each other, but the difference is they have to form right angles. Okay, so they look something like this. The two lines must cross at right angles to each other. And you can see inside of that image that there are four right angles formed when those two lines cross each other. Okay, and then we have parallel lines. So parallel lines never intersect. They go side by side and never cross. So they're going to look something like this. And I put a couple little quizzes in here for you. So as we get through different sets of vocabulary, we'll have a quick quiz. So see if you can answer the questions, and then I will show you the correct answer. First question says, this image shows a blank, and the choices are line, line segment, or ray. So this has an arrow on each side, which makes it a line. Good job. Next, it says this green image shows a line, line segment, or ray. This one would be a ray. It does have one endpoint and an arrow on the other side. True or false, an angle is made up of two rays. That would be true because they share a common endpoint and then they each have one side that continues on. True or false, intersecting lines are always perpendicular. That one's a little tricky. Perpendicular lines are always intersecting, but not the other way around. Intersecting lines do not have to be perpendicular. They can be, but they don't have to be. All right, next set of vocabulary. So we're going to talk about simple closed figures. These are figures that don't have any points of intersection. So if you look at these four images here, the first one has parts where the image crosses over itself. So that would not be a simple closed figure. The next one would be because there are no lines that go through each other. The star is obviously not a simple closed figure because it has lots of lines that cross each other. And the last one is a simple closed figure because there are no lines that intersect. Then we have similar figures. So we're going to look at the difference between similar and congruent figures. So similar figures have the same shape, but they're not the same size. So that would be something like this. They're the same triangle. It's just they start from small and then they get larger. Then we have congruent figures, which have the same size and the same shape. So those are going to look like this. The color's irrelevant. They have to be the same size and the same shape. And if you want to see those side by side, so similar, you can see all the exact same triangle, but just different sizes. Whereas congruent, they have to not only be the same size, they also um, excuse me, sorry. So similar, different sizes, congruent, they are the same size. All right, next we're going to look at polygons. So polygons are 2D closed shapes that have straight sides. So some examples of polygons, triangles, pentagons, octagons. You will not see circles here. Circles do not have straight sides, so they would not be considered polygons. So they're going to start with at least three sides and go up from there. Um, when it says that they need to be a closed shape, it means that all the lines connect. There's no openings in the shape. So these are some shapes that we know. Obviously, a three-sided shape is a triangle. A four-sided shape, here they're showing you a square, but if it were a rectangle or a parallelogram, it could be a quadrilateral would be the correct term for a four-sided shape. Then we have a five-sided shape is a pentagon, six-sided is a hexagon, seven-sided is a heptagon, and then eight-sided is an octagon. And the tricky thing, classifying quadrilaterals. So quadrilaterals are 2D figures. This is kind of a cool image. It creates a hierarchy of the quadrilaterals for you. So quadrilaterals are any shape that has exactly four sides. And this kind of breaks it down for you. So at the top, you see the word quadrilateral. Everything underneath that falls into the category quadrilateral. Right below that, you see trapezoid, which is a quadrilateral with only one pair of parallel sides. And you notice that there's nothing connected underneath that. It's kind of like its own category. So a quadrilateral with only one pair of parallel sides is a trapezoid. But if it has two pairs of parallel sides, it's a parallelogram. So that's that blue one. And you can see there's a lot connected to that. So everything connects above it. So a parallelogram is also a quadrilateral. And if you go down to a rhombus is a parallelogram. It's also a quadrilateral because it's under both of those categories. The main characteristic of a rhombus to remember is that all the four sides are equal. With a rectangle, you see it's also under parallelogram, so it's a parallelogram and a quadrilateral. It has four right angles. Okay, really important for rectangles. It always has to have four right angles. And then down at the bottom, a square is almost everything. Okay, a square is a parallelogram, it's a rectangle, it's a rhombus, it's a quadrilateral. So everything that's connected to it in that diagram it always has four equal sides and four right angles. So a square is all of the things above it except for a trapezoid. Next, we have vertexes. So the points where the sides of polygons meet, and we can label them with letters. You've probably seen this in work before. So here's a rectangle, and the sides are labeled A, B, C, and D. And then we could ask something along the lines of the length from A to D, or what is the angle of point C. And we can learn more about the shape from those. Next, we have diagonal, which is a type of line that you can draw between two opposite vertexes. So it's not one of the sides of the figure, it's just a line that goes from one vertex to an opposite one. All right, let's take a quick quiz about those vocabulary terms. So these shapes are they similar or congruent? Good. These ones are similar. Okay, they are not exactly the same size, but they are the same shape. These shapes are Good. These ones are congruent. Even though they're turned a little bit, they're exactly the same image and the same size. All right, next question. A hexagon has blank sides, 6, 7, or 8. Good. The hexagon has 6. True or false? A square is always a rectangle, but a rectangle is not always a square. Think about that hierarchy that we looked at. Good. This is true, and that's a little bit tricky. Okay, square was at the bottom of that hierarchy, which means it is everything above it, which is includes a rectangle. But a rectangle was above a square. It could be a square, but it doesn't have to be. It's not always a square. Next up, true or false? A parallelogram has only one set of parallel sides. That would be false. If it only has one set of parallel sides, it would be a trapezoid. A parallelogram has two sets of parallel sides. Okay, now we have angles. So let's start with congruent angles. So we learned before that congruent means the same essentially when we were looking at congruent figures. Same thing with angles. So it's angles that have the same number of degrees. Okay, so if you look at these ones, even though the points have different letters on them, the angles are all 63 degrees. So they are all congruent or the same. Then we have right angles, which I'm sure you've seen before. These form perpendicular lines and measure 90 degrees. That's that really nice corner that you get on a square or a rectangle, and you see them all around, like on the corners of our slides. Acute angles, I always joke that they're so cute. They're little, they're less than 90 degrees. So I put a cute little angle here for you. So just remember anything smaller than 90 degrees. It could be 89 degrees, it could be 2 degrees, anything less than 90. And then obtuse would be the opposite of that. So anything bigger than 90. These are some examples. Again, anything from 91 up until 179. Okay, because once you get to 180, we get to our next word, which is a straight angle. So a straight angle is essentially just a straight line. Now there's a point in the middle because it opened up into that straight line. So it was two separate lines to begin with. So when it goes straight like that, it is a full 180 degrees or straight angle. If you want to see them all side by side to compare, you can see the acute angle is the smallest one. The right angle forms that nice corner. An obtuse angle is bigger than a right angle, but it's not straight. And then that straight angle is straight across or open. All right, let's take a quick quiz about angles. So this angle in the picture is acute, right, obtuse, or straight. Good. This one is 90 degrees, so that one is a right angle. The highlighted angles here are acute, right, obtuse, or straight. So you can see those ones are a little smaller than 90 degrees, so these ones would be acute. The angle here is 120 degrees. Is that acute, right, obtuse, or straight? So that one is larger than 90 degrees, but it's less than 180 degrees. That would make it obtuse. And just a few more vocabulary words that we can learn about triangles. So, obviously, triangles have three sides. We've known that forever. They also have three angles, three vertices. But what might be new is that if you add the three angles of a triangle together, it's going to equal 180 degrees. Okay, so if you're looking at a triangle like the one in the image, you can see that there's angles A, B, and C. If you add the three angles of any triangle together, they're going to equal 180 degrees. So say for instance, they give us two of the angles, we can figure out the third one by figuring out what's missing to equal 180 degrees total. Okay, so then we're going to combine some things that we learned. So right triangles, if you think about what the name sounds like, It's called a right triangle because it has a right angle in it. So here's some examples of that. You notice they're not all exactly the same, but they all have a right angle. Then we have isosceles triangles. So isosceles triangles have two congruent sides. And like we've said several times, congruent means the same. So if we look at this image of the triangle, it has two sides that are the same. This also gives it two angles that are the same down at the bottom. Okay, so you can see the two little lines show you on each side that they're equal. And then down at the bottom, you can see that there's two equal angles there. So that is an isosceles triangle. And then if all three sides are congruent or the same, you would have an equilateral triangle. So that would look something like this. You have three angles that are the same and three sides that are the same length. So if we want to look at the three of those together, the equilateral, again, you can see all the sides are the same, all the angles are the same. On the isosceles one, you can see that two of the sides are the same and two of the angles are the same, but the other one is different. And then in the right triangle, you can see that it does form a right angle, but then the other angles are different and the sides don't have to be the same length. All right, let's take a quiz about these ones. So this triangle is right, isosceles, or equilateral. Right, so just like we said that it forms a right angle, it is also a right triangle because of that right angle. This triangle is right, isosceles, or equilateral. This one's equilateral. You can see each angle is 60 degrees and each side is the same length because it has those little line markers on it. And this one's a little bit trickier. So it says the missing angle C is equal to 40, 50, or 90 degrees. I'm going to give you a second to try to figure this one out. I know it only looks like we have one of the angles there, but we can actually figure out angle B pretty easily as well. And then if we remember that all the angles should add up to 180 degrees, we can figure out what angle C is. All right, so angle A was 40 degrees. Angle B is a right angle, so it's 90 degrees. And if we add angles A, B, and C together, they have to equal 180. So we would have 40 plus 90 plus C equals 180. And if we find that missing number, the value would be 50 degrees because 90 plus 40 plus 50 is 180. All right, and that's all for our geometry. I know it's a lot of vocabulary, but again, it's really important to master that before we move on to other skills. So make sure that you practice these words and that you memorize them so that if you see them in the future, you understand what they're referring to.